Hello guys, welcome to today's class. In today's class, we'll be discussing the first principle of differentiation. And in this class, we'll understand what we mean by first principle of differentiation. Now, if you are given the term dy dx, which will mean the differential coefficient of y with respect to x, or the derivative of y with respect to x, the original definition of dy dx is given as the limit of the slope of that function y, which is change in y over change in x, at change in x tend to 0. So the first principle of differentiation gives you the original definition of the differential coefficient of a function with respect to any variable, let's say x, as the limiting value on a slope of the function, which is change in y over change in x, at change in x tends to 0. So basically, when we say first principle of differentiation, it simply shows the basic original way of differentiating a function by saying it as a measure of slope of that function. We impose a limit at change x tends to 0. Now, from the first principle, we can now derive various approaches, various short approaches on differentiation. So basically, let's say you have a function y equal to axn, which we know generally as the algebraic function ax to the power of n. Now, the direct approach on this, if we want to find the y dx, we'll say that the y dx of this will be an x to the power of n minus 1. This is a direct approach of differentiation. But we can derive this using first principle. So first principle is more like the more general way of differentiation, which leads to different direct approaches on differentiation depending on the function. And the original idea of first principle is showing you that the y dx is a limiting value on the slope of a function as tangent x tends to 0. Now let's look at some examples on how to differentiate a function using first principle. Let's look at this example here. If y equal to x squared, find the y dx using first principle. Okay, now let's show this. Let's show how to find the y dx of this function using first principle. So we have a solution here, and we rewrite the problem y equal to x squared, and we want to find the y dx using first principle. The first step of first principle is to introduce your change in y and your corresponding change in x. Remember, we see the y dx as the limit on a slope of a function at change in x tends to 0. Please remember that the y dx from first principle is seen as the limit of the slope of a function, which is change in y over change in x. This is the slope of every function y, the change in y over change in x. But we take a limiting value on this slope at change in x tends to 0. All right? So the first step here is to introduce our change in y and our change in x. Introduce your change in y to every y, introduce change in y to every x, introduce your change in x. So here we have y plus change in y. To every y we add a change in y equal to x. This will be x plus change in x. To every x, you add a change in x and maintain the power here. This is to power 2. Okay, now the next step will be to expand this binomial expression. So we have y plus change in y equal to, if we expand this, this is x to power 2 plus this to power 2 plus 2 times x times change in x. We have 2x change in x plus change in x all squared. Change in x all squared. How do we expand a binomial of degree 2? You say x to power 2, which is this, plus this times this times this, 2 times x times change in x, you have this, plus change in x all squared. Okay, so that's the expansion there. And then the next thing is to make change in y to stand alone. We have a target here. In every first principle, the target is to gradually build up this. To gradually build up change in y over change in x. So we need to make change in y subject and then gradually divide through by change in x and then impose a limit as change in x tends to 0. and then we'll call this our dy dx. That is the general approach of first principle. Introduce your change in y and change in x, then gradually make change in y subject. Later, divide through by changing x, and then finally impose a limit and call that expression your dy dx. So from this, we'll make our change in y subject here. When we make a change in y subject here, it means we are subtracting y from both sides, or we are transferring this y over to this side. So we have x squared plus 2x change in x plus change in x all squared minus y. Okay. Now, but remember, y is x squared, so we can rewrite the value of y. So we have change in y equal to x squared plus 2x change in x plus change in x all squared minus y is x squared. You rewrite the value of y. And if you look at this carefully, you see that this is x squared, this is s squared, they can cancel out. Okay, so this gives us change in y equal to this cancels out this. So you have 2x change in x plus change in x all squared. We've succeeded in making change in y subject, and this part is simplified. The next step is to gradually divide through by changing x. Okay, so the next step, we divide through by changing x. So dividing through by changing x, we have change in y over change in x equal to everything on the right hand side too must be divided by changing x. So you have 2x change in x divided by change in x plus change in x all squared divided by change in x. So we have change in y over change in x equal to this will cancel this. You have 2x plus this will be cancelled by this. You have change in x remaining, just one change in x remaining there. And then the next thing, we've been able to find our change in y over change in x. Now remember, we said gradually we've gotten our slope. This is the slope of a function. For this function, this is the slope, right? Then the next part is to impose a limit on that slope. So introducing the limit, taking the limit on both sides, at change in x tends to 0, we have limit on this slope, change in y over change in x, as change in x tends to 0. We've imposed limit on the right hand side, on the left hand side, we'll do the same on the right hand side. Impose a limit as change in x tends to 0 on 2x plus change in x. If we do that, this will give us, so if I impose a limit on this, change x to 0, this will be 2x plus 0 because this is change in x, it tends to 0. And this whole expression is what we call our dy dx. This means that our dy dx will be 2x plus 0 is 2x. And this will be our dy dx from first principle. Let's look at another example on first principle. We have, using first principle, find dy dx if y equal to x squared plus 2x plus 1. And then let's go straight to solving this. First thing, we rewrite the problem, which is y equal to x squared plus 2x plus 1. And like I said in the first example, the first thing you do is to introduce change in y and change in x. To every y, introduce your change in y. To every x, introduce change in x. Okay, so we have y plus change in y equal to, for this x, we have x plus change in x, and it is raised to power 2, we raise it to power 2, plus 2, for this x, you have x plus change in x. All right, then plus 1. There's no x here, so we just keep it as a constant. So to every y, introduce your change in y, and to every x, introduce your change in x. Now the next step is to expand every expression that should be expanded. For instance, this is x plus change in x to power 2, we expand it, and then this 2 into x plus change in x also expand that. So we'll take that step. Y plus change in y, we'll be having, now expanding this, definitely we'll have, this is x to power 2, x to power 2 plus 2x change in x, 2x change in x plus change in x all squared. Okay, so we open up this two, we have 2x plus 2 change in x, then we have plus 1. After this expansion, the next step is to make change in y subject. making change in y subject. Remember, the target is always having that dy dx is equal to the limit of change in y over change in x at change in x tend to 0. So always have it in mind that you need to find your change in y, make it subject, then divide through by change in x, and then impose a limit. This is what we call first principle. So let's make our change in y subject. We have change in y. We need to take this to the right hand side. So we have x squared plus 2x change in x plus change in x all squared plus 2x plus 2 change in x plus 1. Then we transfer y, we have a negative y. All right, we need to replace the value of y here because y is x squared plus 2x plus 1. So we have our change in y is equal to x squared plus 2x change in x plus change in x all squared plus 2x plus 2 change in x plus 1 minus our y is in bracket, showing that everything here is contained as y. So we have x squared plus 2x plus 1. Now, it is important I put this bracket. If I don't put this bracket, it will look as if I'm just subtracting only x squared. But this shows that everything in this bracket is being subtracted. So if I open up this, I will have change in y equal to x squared plus 2x change in x plus change in x all squared plus 2x plus 2 change in x plus 1 minus into this is minus x squared, minus into this is minus 2x, minus into this is a minus 1. Now from this, you see some terms that can cancel out. You see that this x squared can cancel out this because this minus this is 0. We have plus 2x here, negative 2x here, plus 1 here, negative 1 here, and then we take out the remaining part. The remaining terms, we have 2x change in x plus change in x all squared, and we have this here, 2 change in x, and that's all we have there. Okay, so we've succeeded in making change in y subject and we've simplified the right hand side. The next step is to divide through by changing x. We have change in y. The next step is to divide through by changing x. So dividing through by changing x, we would have change in y over change in x will be equal to each of these terms we divided by change in x. So we have 2x change in x divided by change in x plus change in x all squared divided by change in x plus 2 change in x divided by change in x. So taking this up, we'll have our change in y over change in x will be, remember when I divide this out, I'll be left with 2x plus change in x squared divided by change in x will be left with just 1 change in x, and then this cancels this, we'll be left with 2. Now we've gotten our change in y over change in x. What will be the next step? Imposing a limit on it. We've succeeded in getting this slope. The next step will be to impose a limit on it as change in x tends to 0. So we now take a limit as change in x tends to 0 on our slope, change in y over change in x. And this will be, on the right hand side, we take a limit as change in x tends to 0 on this 2x plus change in x plus 2. And we call this term, this expression here, is our dy dx. So this will be dy dx. And on the right hand side, we take a limit on this expression here. Wherever we see change in x, we write 0. So this will be 2x plus 0 plus 2. This means that our dy dx is 2x plus 2. And that is our derivative.